Let's see working of the decoder. Say the encoder already processed the sentence she's eating an apple and generated vector representations which give the meaning. Now the decoder task is to generate French translation of the same sentence. Let's say here you're going to predict this word. So the rest three words are passed as tokens but shifted to right. So if it's shifted to right, instead of this word which is need to be predicted, you'll get another word which indicates just the start sequence. So now the task is to predict this same word. Remember, this is only used during training. While inferences, the model generates by itself. So with these passwords, we're going to predict the next word. So after that, we generate embeddings for this and positional encoding for this, which I said about in previous video. I'm not good with French, so let's say these maps exactly match with this English here. So for this word, we're going to see the previous word. What do we see? Nothing. So she sees nothing behind. So when you come to the next word, you can see that there is a she. So it indicates that this word, by seeing the previous word, it must be a verb. So when you go to next word, which is an, we see the previous two words, which says she eats. So it indicates that the next word, which is going to come, is probably a noun. Everything which I said is updated in the numerical representation, which is vector representation of the each tokens. So next we have the multi-head attention. And in multi-head attention, the vectors get help from the original sentences encoded vectors, which is coming from encoder, and it enhances its own understanding. And we have the feed-forward layer, where vectors get understanding of the non-linear complex relationships. And it passes to the linear layer. It ensures that vectors are mapped with vocabulary size, and it's passed into the softmax function, which generates probabilities of each tokens in a particular position. And that's how decoders used to predict the next word.